Welcome back again. It's a windy and cold day here in Kansas. I'm happy to be in the workshop. I made a couple videos recently about multiplexing rotary encoders. We looked at a few ideas for handling this. One of them was to multiplex them with a 23017 multiplexing chip, which is a good option. I did that in my previous build and it worked really well. We're also talking about hooking them up normally but sharing an interrupt pin among them through the use of Schottky diodes to isolate them from each other. I did run into a problem with that because sometimes these rotary encoders will land in a position on the detent that holds one of the pins low, and if that happens then that blocks out the other encoders from working since the interrupt pin is being held low. Then I tried isolating the pins through a capacitor, but the capacitor would charge, so it would work for a little while. Then we decided we needed more components, and then I decided that maybe that's not the best solution for a simple solution. While I was bench testing all of this, I decided to try, since they were already hooked up anyway, just connecting them direct like this. And that's what we have here. This is working really well. I don't have a whole lot to add to this video. If you wire it up as shown, the new code is available on my Discord site and also will be published on the Patreon page. Here's an overview of the code changes I made to support the encoders. This is the encoder library that I'm using. It's available in the library manager. This is where we include the header for it. Down further, I've defined pins, looks like 42 through 53, to support the encoders. I've labeled them 0A and B, 1A, A and B, and so on. I'll probably encapsulate this functionality into another header file to do most of the code for us, but for now we're going to go this way, partly so you can see what it looks like, and also because I haven't had time to write the wrapper for it. Go down a little bit further, I've got 6 variables here that hold the value of the encoder. This is where I initiate the encoders. I've just numbered them 1 through 6 with the pins that we defined earlier. In the loop function, I've added a encoders check, which is a function down further I'm going to show you. These are the data refs that are associated with different movements on the encoders. For instance, course on the pilot side up and down, co-pilot side up and down, heading up and down, altitude up and down, so on and so forth. There's a number of ways that you can do this. You could read and then divide by 4. I've decided to do it a little bit differently this time. What's going on is that the variables that I declared earlier will increase every time, and then it resets the value on the encoder. That way it always just changes from 0. When it accumulates enough that it is less than -3 or greater than 3, and the purpose of that is that the encoders, every detent, or at least the ones that I have, are quadrature encoders. So every detent gives me 4 clicks, but I only want 1 click per detent. So I'm accumulating until I get to 4, essentially, and then I'll trigger the command. And then I reset the variable. And that's pretty much it. In my next video, we'll hook up the LEDs, so I'll talk about different ways that can be done. I plan to use a multiplexer, so I can change the intensity of the LEDs if I like, but I'll show you both ways. You could do it without a multiplexer, just hooking up to each pin individually, and that's fine. That's kind of however you want to do it. So I'll see you in that video. I should have it out pretty soon. I got a little behind on this one. I was a little bit sick for a while, plus busy with some other projects, but I'll be back with you again on the LED hookup, and I think there's only a couple other things that need to be done on this project, and then we'll wrap it up. So I'll see you in the next video. Thank you.